Hey guys, this is a tutorial on how to efficiently render a road along a spline or any other mesh that you're trying to follow the spline with. So typically if you look up other tutorials on how to do this, they'll have you make a road mesh that looks kind of like this. And this is just a chunk of a road that it's going to duplicate many times along the spline until it hits the end. And I made this in Blender. It's just this really simple model here. If I go to wireframe, you see there's just a few vertices, and you can make this as complicated as you want. All that matters is that the side, the positive x side mirrors the negative x side, so it fits together nicely if you put it next to each other. And if I drag this into my level here, you can see I have spline points that I can move around. So the road will just extend until it hits the start or the end of the spline. And I can even add spline points in the middle if I right click here. And you can see I can bend the road as well. And this all works pretty nicely. So if I look at the blueprint for how this works, I'm not going to go into how this one works because this is the slow one, but just at a high level, what it does is finds out the number of chunks that it needs to cover the whole spline. And then for each chunk, it adds a spline mesh component. And then for each spline mesh component, it just sets the start and the end position. And it does some math to figure out what those are. And we'll use these, but it uses get location at distance along spline, and you get give it the spline. And it does this for the start and the end, and it gets the tangents there at the start and the end as well. So it's pretty simple. Like I said, there's plenty of tutorials that will teach you how to do this. But the issue with this, if I close this, is let's say that I wanted a really long road. So I'm gonna go to the top perspective and let's see, find my road here. And so let's say that I wanted a road that's say 2 kilometers. So I'm gonna zoom out a little bit. We'll measure out 2 kilometers right over there somewhere. And if I start moving this, you'll see really quickly my cursor's lagging and this is not controllable at all. This is awful. So what you could do, I could undo that and I could open my blueprint and just disable the construction script for a second. And then if I go back to my top view, now I can, this is responsive again and I can move this all I want. So let's quickly make something that looks like a little curvy road here. Say we'll just put a little bend in it. And let's say we'll add one more spline point and we'll bend back. So we have a little bit of an S-turn there. And just to stress the performance a little bit, if I go back to perspective view, let's go over that spline that I just made. Let's reselect it and let's just copy paste this a few times so we can stress test the GPU a little bit. So I have a 1080 Ti. It's not the most powerful card, but it's not an especially weak one either. So let's just make 8 of these. And now if I go back to the blueprint and I turn the construction script back on, see this is going to take a pretty long time to calculate because now we have 8 2-kilometer roads divided by, I don't know, like 2 meters per chunk. So a whole bunch of chunks are being generated right now. So this is obviously pretty untenable, but we'll let it finish just so we can see what the frame rate is. So my frame rate is 30 FPS right now, and we just have 8 roads, so clearly not good at all, and we need to fix this. So let's delete these. And actually, real quick, one way that you can make this a little bit better is you can increase the chunk size. And this helps, but it doesn't make the problem go away. And the bigger you make this, like to make the frame rate acceptable, I'd have to go fairly large here. And at this size, you're going to start to see really hard straight lines on the mesh. So we want a better way to do this. So the plan here is instead of using mesh components, we're going to just have all of the vertices be in a single mesh, and we're going to use bones to have them follow the spline instead of a whole separate component for each spot. So in order to do that, let's just make another folder here. We'll call it the fast way. And let's start by making the model. So I'm going to go to Blender here, and this is Blender 4.0. If you go to, I think, blender.org, if you don't have it, it's a free download. So let's start by just copying our existing road, and we'll make a new Blender file. Let's delete everything that's in there, and we'll just paste the existing road in there, and it should have grabbed our textures too. It did. That's great. So the first thing we want to do is delete the first edge vertices here. So we want everything to be perfectly measured out. So I'm going to go into edit mode and just select all these vertices and delete them. I'm going to select these vertices, and you can open up the little panel on the right here to set exact positions. I'm just going to put them at 0 on the x-axis, so it'll be perfect. And now I'm going to select the faces here. And basically what we want to do is we want to extrude this a bunch of times so that we basically will end up with a giant long road with a whole bunch of vertices. And then for each one of these edges, we want to create a bone. And then for each one of those bones, we want to attach it to just the vertices that are right on that bone. So I don't have time to do this all manually, so we're going to script this all. And one awesome thing about Blender is if you right click on the line over here, you can split the view. So we'll do a vertical split. And I can go into, if you click the top left icon here, oops, I can go to the text editor and create a new file. And I can actually just write and run scripts here right in the editor. So first script we want to do is to extrude this some number of times. So we're going to do import BPY, which is Blender Python, import bmesh, which we'll need later. And all we're going to do is for I in range, let's say 99, which will give us 100 edges. We're going to do bpy.ops.mesh.extrude region move, and then transform OT translate equals, and this just takes a value and a vector. So we'll do 0.500 and close everything out. So this 0.5 here is the amount, basically the resolution of this road. So this is going to, for each extrusion, it's going to move it or extrude it by 0.5 on the x-axis. And so if you wanted higher resolution, you could either increase the number of edges, or you could, well, actually, I guess this doesn't really matter. You could just increase the number of edges if you want higher resolution. This 0.5 just needs to be consistent in the later parts that we're going to do, so just keep that in mind. But this is just the spacing between the edges. So that's all we need to do. We can run this, and you'll see immediately we have a large mesh here with 100 edges. So that's good. The only thing that we need to do is if I go to object mode and I show the face orientation, you see this is all red. This is because the faces are all facing the wrong way. So we can flip that. We go back to edit mode, hit A to select all the faces, and we go to mesh, normals, flip. You can see now they're all blue, and that's good. And if you don't do that and you import this into Unreal, you'll be able to see through the faces. And so just come back and flip all the normals if that's the case. But it looks good now, so we can go back to back to object mode, and we can turn off face orientation. We don't need it anymore. And there we go. So this is all good. We have the start to our road here. That's all the edges that we need. So now what we want to do is create bones for it. So we're going to do that with a script too, because I don't have time for that either. But this script's a little bit longer. So first thing we want to do is make an armature. So let's say armature equals bpy.data.armatures.new. And we'll just call that armature. And then we need an armature object. So armature object equals bpy.data.objects.new armature. And we'll give it the parent, which is the armature that we created up here. So then we need to add this to the scene and then select it. So we'll do BPY context, selection, objects link, armature object, and BPY context view layer dot objects dot active equals armature object. So this will add it to the scene and select it. And then we need to enter edit mode. So BPY ops object mode set and mode equals edit. And I'm not going to spend a lot of time explaining all these commands. You can look up all these functions on the Blender documentation, but I'll just explain what they do as I type them for now. So now we are in edit mode. We have an armature created, and we want to create a parent bone. So in Unreal, you always have to have one bone at the top of the hierarchy. So you can't have multiple bones at the top of the hierarchy. So we'll make a parent one. So parent bone equals armature object data edit bones dot new, and we'll call it parent bone. And we'll do parent bone dot head equals just 000, whatever. Parent bone dot tail equals 0.500. And this doesn't really matter. The parent bone isn't meant to be moved. We just need a parent, so this will stay still. So now the important part, we're going to create a bunch of child bones for this parent bone. So for I in range, we have 100 edges, so we want 100 bones. And we're going to say bone equals armature object data edit bones new. And now we need to pick a name. And we want this to be algorithmic because the name, we're going to use the names to pick which bones we want to move in Unreal later. So let's make a function up here real quick, and we'll just call it def make bone name, and it'll take an index. So we're going to name our bones based on their index. So that's probably a better way to do this, but I'm just going to do if I is less than 10, return bone.00 plus, and then convert that index to a string. I is less than 100, return bone.0 plus string index, else, and then we'll just return bone dot, and then string index. So for 1, this is going to return bone.001. For 2, it's bone.02. If it's between 10 and 100, it'll be bone.010 or whatever. But basically match the format that you would see if you were to just to create bones in Blender. And then back down in our for loop, when we're making the bone, we'll just do make bone name, and we'll give it I. And we'll set the head of the bone to I times 0.5. And remember, before, our edges are all spaced 0.5 apart, so we're going to space all of our bones 0.5 apart as well. And then 0 for Y and Z. And then we'll set the tail to the same except plus that. So I plus 1 times 0.5, so that'll be the end of it. And 0. And then we'll just set the parent of this to the parent bone. So we'll run that. And now I move the editor over a little bit, and we look over here, go to wireframe. You see it created a bone, and they're all spaced at the edges. Or sorry, it created a lot of bones, and they're all spaced as they should be on the edges. And just make sure we didn't have an off by 1 error. There should be 1 bone sticking off the end for the last edge. So this looks perfect. And that did exactly what we want, so that's good. So now we want to go to object mode, and we want to parent the road mesh to those bones that we just created. So I have the cube selected. I'm going to select the bones. Make sure you select those second, and hit Control P, and armature deform, and we'll just do empty groups. So if you see on the right, now our cube is under the armature, and if we go to data on the right hand side here, you'll notice it created a vertex group for every single bone, including the parent bone. If we go back to edit mode, there shouldn't be anything on these. If I click on bone 0 and I hit select, you'll see no vertices get selected because nothing's assigned to them yet. And basically these groups are just which vertices are going to move when the bone moves. And again, the plan here is we're going to align the bones to the spline and the vertices aligned to the bones. And so that's how we're going to speed up our overall road mesh. So we're going to need one more script now, and that's going to assign the vertices to these bone vertex groups. So we can delete this, and all these scripts will be in the description if you just want to copy paste them after the video. So the last script that we're going to make is going to assign all the vertexes or all the vertices to their corresponding bone. And the first thing we want to do is go back to object mode. And in our script here, we're going to get the active object. So UPY context active object. And we're going to get the mesh data from that. So active object.data. And then for I in range, we have 100 edges. So I to 100. We're going to get our, well, first thing we want is for this index, what should the bone be named? So we're going to use the same bone name method that we made before. So we'll do bone vertex group name equals make bone name. So that'll be bone.001, bone.002, etc. So we're going to find the old vertex group that already exists. So old vertex group equals active object dot vertex groups dot get bone vertex group name. That'll get any group that exists. And if it exists, if old vertex group, we're going to delete it. So active object dot vertex groups dot remove all vertex group. And this just ensures that it's empty. So if you did generate the bones with weights, it'll delete the existing weights, and then we'll replace them with the ones that we're gonna make. Now ours are empty anyway, but this is just a more robust script. So now we're gonna make the new group. So new group equals active object dot vertex groups dot new, and the name will be bone vertex group name. Now we want to actually assign the vertices to the respective groups. So there's probably a much better way to do this, but we're just going to iterate over all the vertices in mesh.vertices. And for each one, we're going to get the min x. So I times 0.5 minus 0.1. So basically anything between the start or 0.1 before the start, and we'll do max x equals I times 0.5 plus 0.1, so anything right around there we'll consider part of this bone. So in other words, for the first edge, it's at 0, so we'll take any vertices between negative 0.1 and positive 0.1, and we'll consider that part of bone group 0. So now we'll just check if min x is less than or equal to the vertex.co.x, and it's less than or equal to max x, and it's close enough to be considered part of this bone. So new group dot add, and we'll give it vert dot index, and then the second argument is the weight. We want it to be 1, so it gets all the weight, and we're going to add it, and that's it. So now if we just run this script, it should associate all of these vertex groups with the corresponding vertices. So I'll hit run. And now if we go to edit mode, we can just check that this is the case. So now if I go up to bone group 000 and I hit select, you'll see that all of the vertices on the first edge are now selected. That's correct. And we'll just deselect and just make sure that a couple of them are correct. It looks like they all are. And we'll just check the last one as well. And that is correct as well. So this is all good. And the last thing that we want to check is if we select the armature and we go to pose mode up here. So now when we move these bones, if everything's working properly, the road should also move with the bones. And we see the last one, it does. And most importantly, make sure that it sticks exactly, just to make sure that there are no vertices that are also controlling this and all the weights are set correctly. And you see that line sticks exactly to the bone, so that's what we want. And I'll just check the start bone as well. Oops. And it does as well. And I also want to check that the parent group is not controlling any vertices. So the parent bone should just control all the child bones. It shouldn't actually control any vertices directly. So I can go back to edit mode and deselect everything, hit select, and yeah, there's nothing selected. So the parent bone's not associated with any vertices. That's good. And I guess the last thing is you want to make sure that there's no transforms still on this object either. So if you go to object, apply, all transforms, and same thing with the bones, object, apply, all transforms. It just makes sure that the scale is 1 for everything. So there's no additional transforms that we have to worry about when we export it. I guess there is one more thing we want to do while we're here, and that's go to the UV editor and just make sure that all of our UVs are assigned properly. So I'm going to hide this panel, and we'll go to edit mode once again. I'm going to select all of the faces and we'll go to the material editor over here. I'm going to select inside road and assign it to everything. And then in the top view, I'm going to select, let's see, go back to regular viewport shading mode. We'll select everything and just make sure that only the top is selected. And for the top, I'm going to click road top over here and assign it to the road top material. And this is just so that we can get our nice lines to draw on the top of the road later. And lastly, I'm going to unwrap them. And then over in our UV editor, we'll just line everything up real quick, show our panel. Let's put the center in the center, put the right on the right side, and just get it close. And once everything's close, select everything, right click, and snap to pixels, just to line it up perfectly. And there we go. Now we have UV coordinates as well, and we can save this. So I'm going to save it in that Fastway folder that we created a long time ago, and we'll call it Splined Road. And we can export to an FBX, so file export FBX, so that we can import into Unreal. And the settings we need here are forward should be X, up should be Z. If we go into the geometry tab for smoothing, I'd usually do edge smoothing. We want to make sure everything's triangulated and in tangent space. Everything is triangulated already, but whatever. We go to armature, and this is pretty important. You want the x-axis to be forward, and because Blender is a right-handed coordinate system and Unreal is a left-handed coordinate system, you need -y for the secondary axis, and then uncheck add leaf bones. We don't want it adding any other bones except the ones that we put in there. So that's it. We are in our Fastway folder, hit export, and now finally if we go to Unreal Engine, we can hit import. And all the defaults should be fine. We'll import all. And you can see we have our road top and inside road materials. We have a splined road skeletal mesh. And we have a splined road skeleton as well. So if I open this, you can see that all of our bones are there. We've got parent bone and bone 00 all the way down to 099. So that's all good. If I open the mesh, this looks fine, except we want to put our actual textures on there. So I'm gonna put road top, except the UVs are wrong here, or not the UVs, but the material coordinates are wrong. So let me just copy this material real quick. And if I open it up, I'm just gonna, I had to swap the coordinates for the slow method. So I'm just gonna remove the swap and now they'll be right side up. But all this material does is just sample the texture, nothing fancy right now. And now back in Splined Road, I can select that Road Top 2 material instead. And there we go. So now we have a road with 100 bones in it. And we need to align these bones to a spline in a blueprint. So Unreal provides a class called PoseableMeshComponent that allows you to set the individual positions of bones. But we want to modify it slightly so that we can update the pose from a construction script, and so we can use local coordinates as well. So there's actually another great tutorial that I ran into by 2attack that I'll link in the description below. So check out that channel that shows how to do this, and we'll be pulling some code from that. So first we're going to close the editor, and I have just my tutorial project, C++ project here. And we're going to create just one new class here, and it's called UBpPoseableMeshComponent. So we'll make the header file, and we'll make a CPP file. So in the header file, we'll just do the usual boilerplate, include core minimal. We need components / posable mesh component. And we need bp posable mesh component dot generated dot h. And then we'll make a U class. Now we want to access this from blueprints, so give it a class group, just call it custom, and we'll give it blueprint spawnable component. And then the class will be called UBpPoseableMeshComponent. And we're going to extend from the existing Unreal class, so posable mesh component, and give it the generated body, give it the constructors, and just a blank default constructor, and the fObject initializer constructor. We need a function called setBoneLocalTransformByName, and this function will take the name of the bone that we want to set, and it'll take the f transform that we want to set the transform to. We want this to be called from blueprints, so we're going to make it a U function. It'll be blueprint callable, and we'll give it a category. It'll be components and posable mesh. And we want another function called get bone local transform by name, and we'll return an f transform. And this is just useful for debugging, just to see what the current one is. And lastly, we want an update pose function. And we'll give it the same U function qualifier as well. So that's all this class needs to have. So we'll jump into the CPP file, include bp posable mesh component.h, and we'll quickly give it all of the definitions. So get rid of the U functions. And once again, all this code will be linked in the description below as well if you just want to copy paste it instead. So in the CPP file, in set bone local transform by name, we're just gonna first just make sure that we're initialized. So if we don't have a skinned asset, or if we don't have the required bones, we're just going to return. And that's all just stuff in the base class that we need to make sure is valid before we continue. And then we're going to do int32 bone index equals get bone index from that bone name that we're given. So call the base method get bone index. And if that bone index is valid, so greater than or equal to 0, and bone index is less than bone space transforms dot num, and bone space transforms is the array of the transforms for all the bones. And we're going to set bone space transforms at bone index to the transform that was passed in. And then there's a function that we need to call to mark refresh transform as dirty. Get bone local transform by name. We need to do similar check to make sure that things are valid. But we also need transform result here, and we'll just return an empty result if it's not valid, whatever. And then similarly, we get the bone index by name, like we did before. And if it's a valid bone index, we're going to, instead of setting, we're going to return. And we don't need to mark it. I guess we should use might as well use our result variable here that we set. So we return a result either way. And yeah, so if we have a valid bone index, we'll return the bone space transform at that index. And then the last method we need is, and this one is important, if we change any of these transforms, we need to update all the various systems of the posable mesh component class so that we actually see the change from the construction script. So once again, we'll check that we have a skinned asset and that we have some transforms. And if we don't, just return. And then we want to fill component space transforms. We want to finalize bone transforms. We want to update child transforms. We want to update the bounds. This one's actually very important so that when we adjust our mesh, the bounds get updated, or when we adjust the spline rather, the bounds get updated. Mark render transform dirty, and mark render dynamic data transform dirty, or dynamic data dirty rather. So that's it. That'll update everything that needs to update when we update the transform. Everything should be callable from blueprints now. And so we should be able to build and run to get back into the editor. And I had a typo in the header file. And in bone name as well. So I'll just fix those and rebuild. And what else did I mess up here? Oh, it's the same typo. So now we have everything we need to make the fast version of the blueprint. So we'll make a new blueprint class. And we'll start from actor here. And we'll just call this BP Splined Road, or Boned Road. So if you open up Boned Road, we're still just going to have a spline like the other blueprint did. But underneath Spline now, we're going to use the new class we just created, the UBpPoseableMesh. And then in Posable Mesh, we need to set the skeletal mesh, and this will be the road that we just made in Blender, so Splined Road. And one thing we want to change on this property-wise is search for parent and check use attach parent bounds. So what this will do is make it use the splines bounds and not the skeletal mesh bounds, which is important because otherwise it'll cull the road when it's when you're looking at it, which we don't want it to do. So then go to construction script, and now we'll make the actual magic happen. So grab our BP posable mesh here, and we want to get the number of bones. And then because we have the parent bone, we want to subtract one from this because we only want the number of child bones. So I'll just do -1. And then just to be organized, I'm going to make a variable called numChildBones, and we'll make it an integer, and we'll set it to the number of child bones here. So then we want to for loop over all the bones, and we're going to set all their positions. So the last index is going to be the number of child bones -1, so we'll do another subtract here. So number of child bone for 0 to number of child bones -1 will be the last index. And then we want to get our spline length. And basically what we want here is we want the first bone to be at the first spot on the spline, and we want the last bone to be at spline length along the spline. So we're going to get a number from 0 to 1 based on our index. So let's do a divide. And we're going to divide the current index by the last index so that the last index will be 1, first index will be 0. And actually we need to convert this to a float so it does float division and not integer division. So to float integer. So now we have our 0 to 1 number, and we're going to multiply that by the spline length. So now we'll have 0 to spline length. And we want to get the transform there. So get transform at distance along spline. We'll give it our distance. And then we want to break this. So for some reason, when you export from Blender, the root will have a will be 100x, or it'll have a 100x scale on it. So we want to break the transform and divide by 100 to get rid of that. And I think that's just because of meters to centimeters conversion or something. So I'll divide by 100. And then we'll just build the transform again. So make transform. So pass the same rotation and pass the divided. Okay. And just hang on to that transform. So that's the transform that we want for each bone. So if we go back to our for loop body, we're going to set bone local transform, or sorry, rather, first we need to get the bone name. So I'm going to make a function here called get bone name at index. And if you remember back in Blender, all the bones were called bone.001, 002, 003, etc. So we need to replicate that. And so we'll just do a quick function in here. Make a couple of branches, and we need to match that same format. So make a couple of conditions. Greater than. And then we need to pass in the index. So we'll add an input over here, call it index, make that an integer. And then if the index is greater than 99, and this is that same function that we sort of did in the Blender script earlier. So if it's greater than 99, and if it's greater than 9, we want to check these two conditions. And then if that's true, we want to append, we want to append to a string. So if it's greater than 99, it's not going to have any 0 prefix, so we'll just add bone underscore. And also, when you export from Blender into Unreal, for some reason it renames all the bones. It changes the dots to underscores, so it'll be bone underscore 000 instead of bone.000. Anyway, we're going to append the index to that bone prefix. And then if it's between 9 and 99, we have 10. So if that's false, we'll go here. And we'll append, let's clean up that a little bit. So if it's between 9 and 99, we're going to append bone 0. And if it's none of those, we're going to append bone 00. So this will get us that same name format. Probably a better way to do this, but this works fine. And hook everything up. And just get the nodes out of the way a little bit. Okay, and then we're going to add a return value. So the output will have will just be a string. And I'm going to add a local variable called result as well so that we can streamline this a little bit. So depending on which branch we take, we'll set it to one of these appended variables. So the first branch, we're going to set it to this one. If the second branch is true, we're going to set it to this one. And if that's false, we're going to set it to this last one. And let's again clean this up a little bit. And rename this to the result. And then lastly, we drag our return node over that we just made. We're going to set the results. Why did that not rename? Oh, it's call it output. So we're going to return output. All right, so just check. This is the full function. So we're just trying to create that bone underscore 001 name, and the number of zeros depends on what the number is. So if it's between 10 and 99, I have 1 0. If it is less than 10, it's going to have 2 zeros. And if it's greater than 99, it's going to have no prefix zeros. So that's all this does. Really simple function. Looks complicated. So we can go back to our construction script now. And the first thing we want to do in our for loop body is we want to call that get bone name at index function that we just created. So this will convert our index to a name, set bone local transform by name on that our opposable mesh, and give it the bone name. And then we calculated our transform earlier, so we can just pass that transform. And then lastly, we update pose. This is that last C++ method that we made earlier. And that will update everything that needs to get updated when we change the bone names. So if I just go through this one more time very quickly, our construction script gets number of child bones. And then for each child bone, it calculates the transform. And the transform is just whatever the transform on the spline is at that distance along the spline. So then we get our bone name, we calculate our transform, we set the transform, and we update the pose. So I'm going to save and compile, and that should be it. Oh, and one mistake I made is I didn't connect these sets and get bone name at index. So let me connect those real quick. Recompile. Now if I drag boned road into the level, you can see it looks just like the other one does. And if I click on my my spline here, I can move it around just like the other one. I can still right click and add spline points in, and I can still bend it. It still looks good. And more importantly, if I go to my top perspective again, and I want to create a really long road, see there is no lag at all, and I can just edit the points as I want to. So I can make a similar S-turn that we did at the beginning of this video with the other way of doing this. So we've got a nice S-turn, go back to perspective, and it still looks good. And if I zoom out and I turn my FPS on, you can see I still have 120 FPS. I can even go higher than that if I turn t.max FPS up a little bit. See, we're up at like 130 or so. And if I copy a bunch of these, I think I made 8 of them earlier. So 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 of them about the same length. And if I zoom out, see my frame rate is still right around 120 FPS, even with 8 of these. And this is with 100 edges. If you go to Blender, you can just change those for loops to make as many as you need, whatever resolution. And I've done up to 1,000, and I still have much better performance than I did with the traditional way of doing spline roads. So I hope you find this helpful, and let me know if you have any questions in the comments. Thanks everyone for watching. And if you like my videos, feel free to like and subscribe. I'd really appreciate it if you do. So thanks everyone, and have a good one.